Knock knock.
Who's there?
Probability.
Alright.
From this book. It's Unit 3, new unit.
New unit, new stuff. Probability.
Ideas are brought forward from GCSE. There's a lot of new
A lot of
notation.
yeah, new notation.
Yeah.
Very new.
Now the first thing in the book is in ways of expressing probability is Venn diagrams. So I think we'll crack on straight with that.
Alright.
Have you got a black pen?
You've got,
I've got the black
you've got
pen.
a black pen. Okay. Probability is a chance of stuff happening, and there's different ways of expressing this stuff. Like in Venn diagrams you have a box with a circle in it. The circle represents an event. In this first circle, the event is A, and the whole box, chance of the whole box, all the chance is in the whole box. Like the entire thing will add up to 1, all the probabilities. In the exam, you're normally given one of them. And there's quite a lot of notation to do with all of these circles, and we'll go into it now.
Yes. So if the box adds up to 1, but the circle is the event A, there must be something else there. But it's not another event.
No, there's only one circle.
It's just the probability of A not happening, which is wrote like this.
An A. A little dash.
Yes.
That means not A.
And get out the green pen.
Alright.
The probability that A does not happen, if it's just this one event thing like this, is equal to 1 minus
probability of A. And that makes sense, because the whole thing is probability of 1 happening, because that's the event, or not the event.
An example of this as an event is me throwing this pen to Triv. If he catches it, that might be event A. Event A might be him catching my pen. If he misses it, event A didn't happen, and it's that simple. He didn't catch it. That.
Alright.
And you're given either that or that, and you might have to rearrange his equation. But that's it for that one. We've now got another one.
We have 2 events.
2 events, but they don't touch each other. What's that called, Triv?
Well, that's called being mutually exclusive. That means they don't have any effect on each other. Like if you had a pack of cards, and event A was picking out a heart, and event B is picking out a diamond, they don't affect each other happening. You can't have both a heart and a diamond. You have one or the other.
Yes. And there's an equation for that, and a little new notation.
There is.
Probability of A or, which is represented by a smooth U, snowflake,
of a B,
is equal to the probability of A
plus probability of B.
If they are mutually exclusive.
Yeah, only if these circles are separate.
If they're not mutually exclusive, there's something else, and we'll come on to that in just a second. But there'll be 2 events like that, and like Triv gave you the example, and that's another equation you have to know.
Yeah.
The only thing you really have to remember about this is that means or. It could be event A or event B, but not both in this case, because it's mutually exclusive.
Let's go on to the next diagram.
Now, we have event A and B, and they intersect.
So they affect each other happening.
Now,
you can have both.
You can have both. So, probability of A or B is the probability of A, or the probability of B, or the probability of both.
Yeah.
So it's that, or that. And that equals, like before, probability of A plus the probability of B. But then you minus
probability of both of them, which is like a smooth N.
A smooth N, yeah.
Already upside down in the other version. Which makes sense, otherwise you'd be double counting the middle bit.
Yes. So this one is only if it's mutually exclusive. If it's not, you've got to minus the probability of A and B.
Yeah.
Now sometimes in questions they might ask you to work out the probability of A and B. In which case you've got to rearrange all of this, knowing all of these other things. But don't forget, in this example there's a probability that none of them happen. There'll be a probability here. And we'll go on to it. We'll actually go straight to a question on Venn diagrams right now.
Let's do it. Question time.
We have an example ready. Trev, you ready? I'll read it to you.
Ready? Okay. Yes.
Okay.
Pen.
The question says,
in
a college, the percentage of students who study history
don't have an H.
is 35%. The percentage who study maths
M.
is 50%. And the percentage who study neither history nor maths is 30%. A student is chosen at random. Find the probability that the student studies A, either history or maths.
Alright,
So that's an H-U-M.
Okay, right. You gonna make a Venn diagram of this?
Yes, the first step to all of these questions, where's the red pen? Down here. Is to draw out the Venn diagram. See what you're actually doing.
Alright, in this one you can do both of them, so it would be our two overlapping circles one.
And we know that they don't. The ones that don't do either is 30%, but we do it in probability
So
form.
it's 0.3.
Like that.
Okay.
That is in fact enough information to be able to work out this.
Because this means they do history or maths or both,
Which is in fact the
area of the
in
whole
there.
circles.
We know that the whole box with every one of its contexts will have
It's just
1.
1, so 1,
0.3 is outside it, 1 minus 0.3.
and that's the answer, which is 0.7. And that's the first part done.
Right, so
Simple.
part B, are you ready?
I'm ready. Right,
Go.
let's do it.
Part B says both history and maths, which at this time is probability of H, N, M.
Alright.
So in terms of in our diagram, we're actually looking for this bit in the middle. Both of them overlapped.
Yeah.
So we know how many do history.
We do.
We know how many do maths. And altogether that's 85%, which is
More than our
0.7.
0.7.
The amount more that it is the overlapping part.
Yeah, so otherwise you'd have counted this twice.
Yes.
So the difference is the answer, and that is 0.15. And that's that.
That's it, that's both. But while we're here, I think I might complete this whole diagram.
Okay.
So we know if we put a H here and M here for the two different events. So H is going to be 0.35 minus 0.15, because you don't count that twice.
You don't count the other one twice, no. And say the other side, 0.5, take 0.15, which is 0.35.
And there is a part C, the final bit of the question. You ready?
Alright, I'm ready. Let's do it. Part C.
Only one of the two subjects. Probability of only one.
I don't think there's a short way of writing that.
There is no shorthand
So I
for
will-
writing only one.
Okay.
So we want either this bit or this bit, but not the part
But not the
part
bit in the middle.
So you can probably see from the question it's going to be the 0.2 plus the 0.35, not the 0.15. But in the exam it'll be worth a few more marks and you might
You
have
have
to
to
actually
write it
write
down.
it.
So, how do you write this? Well, first we have probability of H or M. This is one of them happening, or both of them
All
happening.
of this area. And you want to
Minus
the middle.
bit, which is probability of both of them happening, so P, H, N, M. And number form,
And that equals 0.755.
oh yeah, but 0.7 minus 0.15, which is
Yes.
that.
Yes. So like I said, you can probably see from the question it's that plus that. But to write it algebraically, or in its notation, you've got to write it like that.
Yeah. That's pretty much the gist.
That is the gist.
I think that's all the Venn diagram sorted.
Yes. What are we on to next then?
I think it's conditional probability.
Conditional probability.
Stuff starts happening because of something.
Yes.
The chance that I leave the scene, given that Wayne's left the scene,
It's 100%.
is 100%. So okay. Right. Conditional probability.
Conditional probability is the probability of something happen, given that something else has already happened.
Yeah, like the probability of it raining tomorrow, given that it's rained today.
Yes.
There's a way of writing this as well.
Yes, there is.
Probability of A, an event, given that, which is represented by a line, B has already happened, and that's what that line means.
And as well as there being a way of writing it, there's a formula for working it out.
As all of these things. And the formula is probability of A and B happening over the probability of B happening, which should make a lot of sense.
We have an example question to go through.
Yeah?
You ready for it? I'll
ready
read
for
it.
it,
I'll read
yeah.
it.
You read it? I write it?
Yep.
We'll do it. Okay.
It says Dawn has a collection of photos, and this table shows the number of photos in each 4 categories. So you're ready to draw a table, Triv?
Yeah, it's a two-way table?
Yes.
Alright, yeah.
Across the top is people and places. These are the two things that could be in the photo. It could be a photo of people or a photo of a place. And down the side of the two types, there's glossy
Yeah.
and there's matte. No. question A says, given that the photo is glossy, what is the probability that it shows people?
Okay, I think we need some numbers.
Oh yeah, we'll put some numbers in the table. Top left is 44. Next to it is 36.
Okay.
Bottom left is 26. And then next to it is 14. So given that the photo is glossy, what is the probability that it shows people?
Given that glossy.
A, given that G in this case.
Okay.
Okay. So you can sort of logic with it, but we're using the top because it's glossy. It's given that it's glossy, you can just ignore the matte. So we need to make sort of like a population of the given that point.
So we need a total.
44
plus 36, which is 80.
That's how many's in the top. Now we want the probability of A happening. And A is just the 44.
It is.
So the probability of A and B is the probability of A and G in this case, which is 44. Over the probability of B, which we've just done, the probability of B is G in this case, which is 80. Which equals what? Where's my calculator? There's my calculator.
Alright, quick get calculator.
You ready? 44 divided by 80.
Bit more
0.55.
0.55. Most chance of that happening.
Yes. There's a part B and that'll be it, that's all there is. But you ready?
Yeah.
So now it says, given that the photo shows places,
Alright.
what is the probability that it is matte? So in this case matte is M, so it's the probability of M given that B.
It's a bit nice this one, because the probability of B is
exactly the same up here.
Yeah.
So B is this side, so now we can just ignore the left hand side of this table.
We can.
Got to add 36 and 14 together.
So that's 50.
Equals 50.
And the thing we want is matte.
Yes, the probability of M and B is 14.
So 14.
Over the probability of B, we just said is 50. 14 divided by 50
is
14 divided by 50.
0.2 something.
0.28.
Yes. And that's the question.
That's conditional probability. There's more practice questions in the book, but we're not going to go through any more in this video.
Yeah.
Next, we're on to tree diagrams.
Which uses this a bit.
You what?
Which uses this quite a bit.
Yes, this is very much conditional probability stuff, but a different way of displaying it. So let's get on to that.
Crack on. Tree diagrams.
Again, it's a revision of GCSE, but we'll develop it a little bit more.
Yeah. Tree diagrams is another way of representing probability diagram. Yeah, let's go through them.
Yeah, what if I have a fair dice, a fair six-sided dice, and I roll it, the chance of me getting a 6 is a sixth.
We're saying it's a very fair roll dice.
Yeah?
Yeah.
The chance of me not getting a 6
It's
is
5,
5
6.
6. And if I roll it again,
Be the same chances again.
same chances.
So the top 6, the other one has to be a 5, 6, even without logicking out. Sometimes they put a tree diagram up like this, but it leaves some of the values out and you have to fill it in.
Yep.
So I did it at GCSE as well, but I don't know. Do it again because it's stats.
Yeah. So if I asked Triv, what's the probability of me rolling a 6 2 times in a row? How would you go about doing that?
Wow. Well, it would be very likely, but you follow this line up. You sort of treat this line here like a multiplication sign. So you times the 6th by the 6th.
Yes. So you get a 6 and you get a 6 again is 1 over 36.
Yeah.
That's your chance of getting twice. You can do the same with all the other things. You can get a 6 and not a 6, not a 6 and a 6, and not a 6 and not a 6.
So I'll fill those out anyway, so that'd be 536.
Yep, that'll be 536. This one will also be 536.
And that one would be 2536.
So you're, the one with the greatest chance is you not getting a 6 and then you not getting a 6 again.
Which makes sense if you think about the dice.
Now we have an actual question here.
We do.
So, do you want to rub this out?
I'll rub this out.
And I'll go get the question.
Alright.
I'll read it to you. so in this question there's a little bit of filling in, like Triv just said, in this question I'm doing now.
Right.
A trainee has two tests, A and B. The probability of passing A is 0.8.
Right, so that'd be passing A. Should we leave it and I'll fill it in later?
If the trainee passes A, the probability of passing B is 0.9. If they fail A, the probability of passing B is 0.6. And that is all the information it gives you, so all the other values Triv will have to work out himself. Every branch will add up to 1.
It will. So this side, you'll either pass it or you won't pass it, so add it to 1, so it'll be 0.2 here. Here it'll be the same, this will be 0.1. And here it'll be the same, it'll be 0.4.
Okay, now part A says find the probability of passing B.
Okay, let's do it.
In probability questions, the word and means times and the word or means plus as a general rule. So the probability of passing B, you can either pass A, then pass B, which is 0.8 times 0.9, or, which is plus,
you can fail A and then pass B, which is 0.2 times 0.6.
My calculator's there.
Alright, right. So
you've got to look at all the different paths available to do what the question's asking you to do.
and that equals 0.84. That's quite a high chance of that happening.
It is. There's a part B.
Okay.
You ready?
Yeah. Part B.
Part B says, find the probability of passing at least one of the tests.
So that would be A or B.
Yes. Because that means A or B or both.
Yeah.
Now you could do like this. You could pass both. You could pass that, then fail that. You could fail that, then pass that. But another way of saying that is 1 minus the probability of failing. So this 0.2 times 0.4. 1 minus that. Because every other alternative pathway you can do apart from this one, you do pass at least one. So, what's that, Triv?
I'm unsure how I found it. You can find your hands button.
Ah.
It's 0.92.
0.92, I'll put it just under here, 0.92. There's a final part to the question if you're ready.
I am ready. Okay, so part C.
Given that the trainee passes B, find the probability that they pass A.
Given that
B.
they've already passed B. We've just gone over this in conditional probability, so you should know how to do this.
Yep. By our
Right.
formula, probability
We have
of
A and B over the probability of B. We have probability of B, and we have probability of A and B, I think, do we?
Yep, A and B is 0.8 times 0.9. What's that, please? Probability of pass both
0.8 times 0.9 is 0.72.
0.72 over the total chance that you pass B,
Which is 0.84.
0.84. What's that then?
It's 0.86.
0.8.
So two decimal places.
Okay. I'll put that down here just so it's with the other answers.
And that's how you do that question.
And that's linking in the conditional probability we just learnt with
And
some
general
GCSE
probability.
stuff.
And using the notation.
Yeah. Now let's get on with the course.
The back.
Test yourself, page
Yeah.
51, question 2 of this book.
Oh. This book. We're going to do a past paper question.
What year is it from?
It's from 2002.
So, yeah, that's good.
That's good.
This question can come up, that just goes to show. That's why we do it. These
From
ones.
exam board. Yeah. Papers.
I'll do A, you do B, maybe.
Yeah?
Yeah?
Yeah, okay.
Alright.
Right, so I'll read the entire question.
Okay, we'll explain what's going
A
on.
bottle bank consists of 3 containers, one for each green, brown, clear bottles,
That's this side.
That's
that this C stands for container. Green, brown, clear.
Yeah. The notice says people should put it in the right bottles, in the right banks, but they don't do it right. This table summarises where the last 200 bottles in the bank were placed. For example, 15 brown bottles were incorrectly placed in container for green bottles. Whew, that's just a build-up.
So, this is the colour of the bottles, green, brown, clear. This is the colour of the container that they were put in.
Yeah, that's not always right. And part A says, one of the 200 bottles is chosen at random.
Right.
Find the probability that the chosen bottle is AI, green, and correctly placed in the green container.
Okay.
So, that's like a thingy question as well.
Okay.
So we find probability that it's green. Well, we want that bit, really.
Yes. So the probability that it's green and placed in the green container is only that box.
Yeah.
It's 85 out of
Total.
200, did you say? Yeah.
Yeah, so it's 200.
So it is literally just 85 over 200.
And that's the first part. AI
Alright, Captain.
is just any of the bottles placed in the correct container.
Okay.
So, this sort of diagonal line is the correct container. So 85 plus 45 plus 34. And is that over 200 as well?
That's 64 over 200. Yeah.
Yeah.
Sorry, I was doing
And
my
that's
maths
AI.
before I answered your question.
Yeah. And AI
Captain.
placed in the correct container given that the bottle is clear. Oh, it's making a bit of a...
You talk through what I'm doing. I'm just looking at
Probability.
things.
Okay, so we want it being correct container, like there, given that the bottle is clear. Basically, we want that bit. So, for our formula before, we had probability of both of them happening over the probability that bit happens. So, yeah, 34 over 45.
Yeah.
Because probability is
34
clear.
is clear and clear.
Yeah.
And so the probability of clear is these added together,
which is 45.
But that's what it's not very clear because it's brackets in the letter C, which is a bit of a bugger. But I put probability that it's clear, given that it's clear, and that doesn't really make sense in this. You know what I mean from the question.
Yeah.
Is that it, or is there a
No,
part 4?
that's it. Now we're on to B.
All right.
Swap
Do you want to
around?
use a different colour?
I think I will. I think I'll use red. The
Red?
nice red.
I've got the red.
Oh, fantastic.
You give
You
me
know the book?
Okay.
Right, B time.
There's 3 parts of this as well, but B part 1.
Right.
It now says that 3 of the 200 bottles are chosen at random without replacement.
Okay.
Find the probability that the first bottle chosen is green.
Okay.
Now, it says that they're not placed back afterwards, but in part 1 that actually doesn't matter because it's the first one that's being chosen is all we're interested in. So the chance that it's the bottle that's picked is green is 85 plus 4 plus 1, which is 90, out of the 200 you could have possibly chosen. And that is it. That's all it's interested in. So 90 over 200 is your final answer.
Right.
Right. Part 2 says all of them are green. This is a bit trickier.
It's a bit tricky.
The chance that the first one is green we've just done, that's 90 over 200. The chance that the second one is green, because it's not replaced once it's taken out, there's now only going to be 89 green bottles out of 199 that you could choose from. And then there's going to be 88 green bottles out of 198 you can choose from. But it's and, so it's times in each of these bits, because you have to get that, and then that, and then that. And my calculator has disappeared.
Oh dear.
Oh dear, where's my oh, I found it,
Ah, that's good.
It's hiding
like a
beneath.
jewel, this thing.
It's hiding beneath the donuts.
Ah.
90 divided by 200 times
Quite a build up.
89 divided by 199 times 88 divided by 198 is 0.089. 894. You should probably extract it to 3 significant figures.
Yeah, it's a good habit to get into. I didn't on the last question,
But you didn't need to then. That wasn't relevant.
but this one you should. Right.
Now, part
Aye,
3, aye, Kevin, is that 2 are green and then 1 is brown. Now, this question is a particularly tricky one in terms of getting your head around what it's asking. You can get the first bottle green would be 90 out of 200. And then for the second bottle to be green, if you've taken that out, there'll be 89 green bottles to choose from and 199 total bottles. And it's times, because you get that and that, and it'll be timesed again by the brown one, 65, over the amount left, which is 197. Oh, no, you've done that wrong. It's 199 there and 198 there.
Yeah.
Right? And that equals, I will do it, wait a moment,
Okay, so
90 divided by 200
times 89 over 199 times 65 over 198. And that is
0.0661. But that isn't the final answer. Because you can get a green and then a brown, but you can get a green, then a brown, then a green,
you can have
and a
three
brown,
different
and a green,
ones.
and a green. So this number is actually times by 3,
Yeah.
which gives the actual answer, the full answer, 0.198 to 3 significant figures. And that's a tricky question to get your head around, because there's more than one way that you can get the thing you're looking for. And you've got to try and think of the number of ways and then times it by probability of each way.
We do that a lot more with binomial stuff.
Binomial, you actually learn formulas for the really big possible numbers of ways of doing things, and how to work out how many numbers of ways there is to do things. But that's not until chapter 5. Chapter 4, what is chapter 4? It's not that yet. First we've got discrete random variables, but then it's binomial distribution.
Okay.
That's a tricky question to get your head around.
But yeah, that's that question.
That's your test yourself, the AQA 2002.
Alright. Let's get on to the summary.
Sorry.
Alright.
So,
Yeah. Stats.
yeah, chapter 3.
Probability. It's quite an important one.
We started off with Venn diagrams.
We did, and explain a lot of the notation
Yep.
of how it works.
What's it called if the two can't happen together?
I was about to say that. It's called being mutually exclusive,
It is indeed.
and some of the equations, formulas work differently for those.
Yes, probability of A or B is the probability of A plus the probability of B for mutually exclusive ones.
Yeah, but when it's then a not mutually exclusive, it's minus the probability of both happening as well.
Yes, and you've got to remember that. We then went on to conditional probability.
We did. Something, given that something else has happened, we have a notation of that, where it's probability of A, line B.
There's quite a lot of notation.
There's loads, yeah, you get your head around it all. Also there's one where probability of it not being, where there's a dash, which I did mention 2 seconds ago.
Oh yeah. Then we went on to tree diagrams.
We did.
There should be a revision from GCSE. There's not much development in the book, it's just perhaps harder examples to get your head around.
How they work, and the line is pretty much a time sign.
Yes, yeah. As you go across its times.
Yeah, and then when you have things and something else, you times them.
Yep.
And
if it's something or something else, it's plus
yeah.
in probability.
Important to remember. And then we did a test yourself
We
question.
did a test yourself. Genuine from a paper, as always.
Yeah, as always. And there was an awkward thing to notice. You had to do 3 different arrangements.
Yeah.
Of the last thing.
And that is
nearly
always in the exam.
They like doing that sort of thing in probability, like hiding something in stats in general.
Yeah.
So look out for.
That's chapter 3. It gets built on over the next few chapters, but
It
it's
does.
chapter 3.
Next is discrete random variables.
Yeah.
So, yeah.
He's been James Trevette.
He's been Wayne Lack.
If you have any questions or comments, put them below.
Please don't. No, do. But it's the stats.
It's horrible.
It is not nice. But I'm sure we're not any people who don't find it nice. So, yeah, do put them down. We'll answer as much as we can. Hopefully it'll help us as much as it helps you.
Yeah. But that'll be it for today.
Yeah.
We're done.
Alright. See you next time.
See you chapter 4.